Hello, my name is Bolaji Bamiro and I'm from Nigeria.
Okay, my name is Tshenolo Daumas and I'm from South Africa.
Hi guys, I'm Tatenda Emamatika. I'm from Zimbabwe.
We are on a research fellowship and it's a collaboration between the University of Tübingen here in Germany and the African Institute for Mathematical Sciences. We are five in number. I work with the climate and soil science groups while the rest work with computer vision, medicine, linguistic, and robotics.
Can you please tell us your research topic?
Okay, so my research topic is implication of climate change on agriculture. In case of droughts, impact on crop yield.
Okay, can you explain a little bit more about your topic? Like, what is it about?
Well, I work with the machine learning in climate sciences group and the soil science group, and I majorly make use of climate data, which can be gotten from satellite data, and then I work on the extraction of climatic variables and see if there is any correlation between these climatic variables and crop yield. So there are different kind of crops. We have the summer and the winter crops. We have maybe maize or wheat. So I majorly work on knowing how perhaps temperature or rainfall, soil moisture has an effect on the crop yield in a particular region. So a region could be in a particular country. Let's say South Africa. I could investigate a region in South Africa, one of the provinces, maybe KwaZulu, and then see how the climate in that province affects the particular crop during its growing season.
Okay, that's good. So, are you working with any machine learning models?
Yes, eventually once I've extracted all the climatic variables, I would use I would work on a neural network that takes in these variables and see how much of the crop yield can be predicted or forecasted. And this would definitely help in making decision making in agricultural production.
My research is in representation learning in applied in medicine. So specifically in single cell biology, what we're looking at is dimensionality reduction methods and how sensitive they are to input variations. So in my project, since we're dealing with dimensionality reduction, those methods that are popular in single cell biology are PCA, so principal component analysis, and UMAP, which is uniform manifold approximation and projection.
Okay. Can you please explain a little bit more about PCA and UMAP?
So PCA and UMAP, specifically in single cell, well, when we're dealing with single cell data, right, it's part of a process, so a pipeline from when you get the data's input to visualizing the data, right? So the thing about single cell data is that it's highly dimensional. So in order for you to visualize it, you need to project it into a space that is either two-dimensional or three-dimensional, meaning that you have to reduce the dimensions of the data, right? So what usually happens is that PCA is applied on the data, on the high dimensional data, and then you from PCA you get the first few significant components or principal components, and then from there you use the first of those significant principal components, and then UMAP is then used to it uses those principal components in order for the data to be visualized into 2D or 3D, depending on what your preference is.
Okay.
And where PCA is linear, UMAP is non-linear, so it can handle more complex data.
What's your topic?
My topic is analyzing attentional processes in social interaction settings.
Can you explain more about your topic?
Okay, so my topic, it's a broad topic. So it's analyzing what a person focuses on in terms of their eyes, what they're looking at when they are in a social interaction setting. So that's basically, it's when you're in a group. And for my case, it's in a classroom setting. So it's for teachers and students. And we are analyzing the visual attention of a teacher while she's giving a lesson in a classroom. Do you recommend this fellowship to anyone?
Yes, I would. I would, especially to people who are looking for opportunities beyond the borders of their countries, because I know that a lot of people may feel comfortable in their spaces, but there are those people who feel that they want to really, broaden their horizons and their worldviews. And traveling is a very important part of that, because you get to meet different people from different cultures, you get to experience different places, eat different food and all of that. And all of that comes with a lesson, and it's always good to be more than what you have been for your life. So this fellowship really provides that, and because of that I would recommend it. Highly recommended.
Yeah, I mean, if you're interested in the fields of data science, AI, or machine learning, this is a really good place to be, because there are a lot of resources, research groups, people working in related stuff. And in terms of this fellowship, the people who organized it for us are really helpful. So it's not just about the work, it's also about personal stuff. They're really helpful if you want to know how to go about something. For example, even the basic stuff, for example, when you get here and you're like, I don't know how to find a gym, they will help you with that. So yeah, I would recommend it to anyone who has similar research interests, because also University of Tübingen is one of the respected universities in the field, I guess. So yeah, it's good. It's also a good opportunity for you to network and meet people from different countries who are in the same fields, I guess. And yeah, just to know about stuff. So I think it's great.
Okay.
Do you recommend this to someone else?
Yes, I would definitely recommend it. It's not just that you would have a great research experience, career development. The culture here is also interesting. I had a lot of fun learning the languages. I also went on an European tour where I got to experience other countries surrounding Germany, and it was very great and enlightening and eye-opening. And I was able to see that there are actually other things besides my country. So I wasn't what's the English word for that? I wasn't myopic.
Short-sighted.
Yes, but there's like myopic. So in terms of my research view, I wasn't myopic. I was able to see and experience different cultures, talk to different people, and we shared ideas and collaborated, and being able to experience that has made me, expand, like have this panoramic view of what research could be, and I actually enjoyed that. So I would recommend this program to anyone who is interested, because there is development, growth in research, presentation writing, and so many other areas actually. So My network of researchers has also increased, and it's definitely what is needed to actually move forward in one's career. So I would recommend it to anyone because of these benefits and the experience and the enlightenment. So yeah.
So, what's the most interesting thing that you've learned so far in terms of work?
Well, I've learned a lot of interesting things, but one thing I would say is the presentation skills. So initially, I was presenting based on my presentation was not so good, was a bit clustered with too many information, and then my supervisors got to help me understand how these presentations should be, and I improved on that. So that was quite interesting because you needed to have seen my presentation before. You wouldn't even want to sit through it. But now, definitely, you would understand what I'm saying, and then the input, like the message I'm trying to pass across, will definitely be passed across. So, I wanted to say something else, but I can't remember. But another interesting thing also is being able to see other countries. So I traveled to other countries surrounding Germany, and oh my gosh, you should travel. It's so interesting. They had the same system, but I mean the places I saw, I'm not going back, guys. And what have you learned so far?
Okay. So I had never worked with videos before. So this is the first time I'm working with videos because some of the data that I'm working on, it's a video recording of the whole classroom scene. So I've learned how to work with videos, and I've also learned that they are really difficult to work with because when a person is moving, the images are blurry, and it's even terrible if the lighting is bad. So yeah, I've learned that you really need to do a lot of work, not just try to use most of the pre-trained models, because most of them were trained on data that has good lighting. So I've learned that. And the other thing I've learned is how to use SSH, because I thought it was really simple because most people talk about it, but this was my first time having to do my work based on a server. So I have to connect to a server almost all the time I'm doing my programming work. So yeah, I had to learn how to use that when I'm at the office and also when I'm at home. Yeah.
Okay, so I've never worked with dimensionality reduction.
Mm-hmm.
So my background is in neural networks. So anything that has to do with machine learning or data science has always been neural networks for me. But now moving into the space of dimensionality reduction, I'm finding myself having to go back to what I learned in my bachelor's and my honors, and trying to apply this into real life and into solving research questions. So I could say that what I've learned so far is the whole, I would say, subset of machine learning, that is dimensionality reduction. The whole subdiscipline itself is something that I've learned so far, and I continue to learn.
Okay. So I'm going to ask you 3 questions from Twitter. Okay, so the first question that we have here is what AI skills should you start with learning?
Okay, so AI is a really big field, so that is very difficult to say what exactly you should start learning. So I think the first thing would be to identify the field that you're interested in, because AI has many subfields. So for example, you're interested in machine learning, you can start with I would suggest to look for basic tutorials on machine learning on a particular maybe topic that you're interested in, and then you just follow the tutorials, and most of them will start with programming in Python. So yeah, so maybe you can start with that.
So, what is dimensionality reduction?
Right. Dimensionality reduction is basically simplifying data in such a way that, for instance, I'll give you an example. Say you want to understand a 3D cube, right? And you want to look at it on a screen. It will appear as a square, right? Because it has moved from a 3D representation or 3-dimensional representation down into a two-dimensional representation.
Okay.
So, as an example, I think that explains what dimensionality reduction is.
The third question is, how can machine learning help to feed 9.8 billion people in 2050?
So we all know, I don't know if we all know. Okay, so this is how machine learning works. So machine learning takes historical data, and based on that historical data, we can make a prediction of what would happen. So if from our historical data, we can see that based on our projection, there would be maybe shortage of food supply if an action is not taken. So using machine learning, we can be able to predict based on variables agricultural productivity in the nearest future, and we can make decisions now, what to do now so that it doesn't affect our food supply in the future. So I would say that machine learning would help as an early warning system. So, and then it can also help us to know what to do and what not to do now, how to mitigate the declination of food supply, the decline of food supply, or how we as individuals or a community can adapt to those changes. So,
Okay, that was nice.
thank you.